So today is the beginning of Module 8, which is actually our very last module of 7th grade, and it covers probability and data. So today we're actually going to be focusing on probability of certain events and how we can represent them as either impossible or certain, and the range in between as represented on a number line. So we're going to go ahead and take a look at the example above. And I know we've already discussed a lot about different cases of probability with a spinner. And we've looked at vocab on things that are equally likely or certain or impossible to happen. So we're going to put all of that together in this problem. The figure below shows the probability scale, again, from impossible all the way to certain. So we're going to decide whether each event would be located on the scale above. And we're going to place a letter for each event in the appropriate place on the probability scale. So for some reason, the letters messed up whenever I transferred. So this should be situation A, situation B, and situation C. So in order to do this, we need to read each example and determine what is the likelihood of these situations happening. So I know that for option A, it says you will see a live dinosaur on the way home from school today. So what is the possibility or probability of that happening? Well, I know that all dinosaurs are extinct, so that this is a 0 chance. So like we can write dino over total chances, right? The opportunity of seeing a dinosaur over the amount of like total animals or total things that we see on the way home. Well, dinosaurs are extinct, so that would be 0 out of who knows what the total is of things that we see. So realistically, it doesn't even matter the rest of this fraction, because when I know that a dinosaur walking down the street on the way from home is a chance of 0, then that is the probability. It is impossible. It is not likely to happen at all. So this event for A goes above 0, impossible. And the reason I'm writing this fraction over here is going to come up later when we have events that aren't completely impossible, right? So we need to keep that there as a preparation for another event that comes up later. So event B, a round disc with one side red and the other side yellow will land yellow side up when flipped. So let me read that one more time. If we have a round disc with one side red and the other side yellow, what are the chances or the probability that it will land yellow side up when flipped? So the event we really care about is yellow out of the total outcomes or the total options that it could land on. So let's go ahead and think about that. I wish I had a yellow marker, but I don't. If there's a round disc with one side red and one side yellow, how many sides are yellow again? 1. And how many total sides are there? How many total outcomes could it land on? Well, it could land on red or yellow, which is a total of 2 sides. So the probability of it landing on yellow is 1 out of 2, or 1/2. So I see that 1/2 is right here. So that means that event B is equally likely to occur or not occur, right? It is even. It could land on red, it could land on yellow, and those chances are equal. Now looking at event C, I see that it has a spinner with 4 equal parts numbered 1 through 4, and we want to know the probability that it will land on 4 the next spin. Okay, so a spinner with 4 equal parts numbered 1 through 4 will land on 4 the next time it spins. So we want to know when it lands on 4 compared to the total options it could land on. So if I look here to set up my fraction, I know that if we had a spinner with 4 equal parts, let me just go ahead and draw it out. 1, 2, 3, 4. I see there's only one section that has the number 4 on it. Out of how many total sections do we have? 4. So that means the probability of landing on a 4 is 1 out of 4, or 1/4. So if I put that on my number line, where would it fall between 0 and 1? Well, I know 1/4 is less than 1/2. In fact, it is actually halfway between 0 and 1/2, so event C goes here, which means it's unlikely to happen, but there is still a chance, right? It's not impossible. And sometimes that may be hard to determine where fractions go when we start comparing them. And so the cool thing is that we already know that we can convert fractions to decimals and to percents, so that comparing them becomes that much easier. So I could look at 1/2 first. And in order to convert it to a decimal, I know we use our handy dandy bow tie strategy to place the numbers in our house. And so when I go ahead and divide them, I know that 2 goes into 10 5 times. And so the decimal option is 0.5. And then I know that to convert a decimal to a percent, we use Dr. Pepper, Dr. P. And that means that we're going to move that decimal point 2 places to the right to make it a percent. So that would be 1, 2, and we're going to fill the gap with a 0. So this percentage is 50%. So let's go ahead and add that next to our information here. So the probability of flipping a yellow side on a disc is either 1/2, 0.5, or 50%. I'm just going to add that above my scale. So go ahead and add that above your scale as well. And we can do the same thing here with 1/4, dividing using bow tie. And we know that 0.25 as a decimal. And we know that 0.25 converted to a percent would be 25%. And so now we can clearly see that this is a lot easier to put in order. So let's say the decimals were hard to put in order. We couldn't tell that 0.25 comes before 0.50. Right? Maybe that's a little struggle or a challenge for us, but I definitely know 25% is less than 50%. That looks like an 80. Therefore, it has to go in between A and B. So 25% would go here and 0.25 would go here. And so that is going to be super helpful to know that we can use fractions, decimals, or percents to put on our probability scale in order to make sure that they are in order. Because if I had 0 as being impossible and 1 being certain, that's like saying 0% to 100%, right? And so we know that if it's a scale from 0 to 100%, converting these probabilities to percents can be super helpful in our upcoming examples. So let's go ahead and stamp that probability is a measure of how likely it is that an event will happen. So this number will fall between 0 and 1, where 0 is impossible and 1 is absolutely certain to happen. We can represent this on a number line using fractions, decimals, or percents. Let's go ahead and try some on our own.